Welcome to clickmyproject.com. Let we discuss about the process tracking human under occlusion based on adaptive multiple kernels with projected gradients. Let us see the abstract of the process. In video surveillance applications, the main aim will be the identification of the persons, that is, identifying the position of the persons in each frames of the video. Tracking of the targets in the video has many applications in surveillance systems. The specific persons or vehicles in the videos can be tracked using multiple kernels tracking process. The persons in the videos were tracked all over the video frames. The positions of the targets in the videos were trained in each frames, and the positions of the targets in each frames were identified. Based on the identification of target positions, the target is tracked all over the frame. There are numerous techniques commonly applied for the identification of the persons. Yet, the identification of the persons in the video remains a problem. A method that uses multiple kernel tracking method for identification of selected target position in the video is proposed. The position of the target that are to be tracked in the video is given as the input. The position is learned in each frames by the use of prediction and the estimation processes. In the prediction processes, the positions of the targets were predicted by identification of the movements in the pixel coordinates. The predicted object positions were compared. The movements were detected by means of the employment of particle filtering, which denotes the movements in the specified target position. The processes generation of the identification of moving pixels in each video frames. The predicted positions were estimated with the help of the trial and error method for the estimation of the target pixel coordinates. In the methodologies, the error rates were identified and the particular pixel locations where the error rates were minimized and the positions were compared. If they were same, then the predicted positions were chosen, otherwise updation process is estimated. The estimated target coordinates were then again estimated, and for the whole video frames the process is repeated, and we can keep in track of the needed persons all over the frames. The predicted persons were denoted by rectangle to denote the locations. The performances of the processes were measured in terms of accuracy and error rate. The measured performances shows that the accuracy of the proposed system is improved compared to the other existing methodologies for the tracking of the targets, which is due to the employment of the methods based on kernel learning. Let me see the flow of the processes. Input video is selected, the video is converted into frames, then pre-processing steps were implemented. These are all the basic processes that we are doing here. The input video must be taken from the static cameras, and the videos must have the empty background regions so that we have to estimate the object positions initially. So after the pre-processing step, target coordinates were predicted based on the background subtraction methodologies. So here we subtract the each frames from the reference frame. The reference frame denotes the empty background that is obtained in the videos. After that, the learning processes is employed. The learning denotes the identification of the pixel positions in each frames of the videos. This learning continues till the completed frames. After that, the prediction of the learning processes were estimated. Prediction denotes the identification of the exact object positions in each of the frames. So for learning and prediction, kernel based methodologies were employed. The kernel based methodologies refers to the checking of the conditions in order to select the object locations. The prediction and the learning were combined with the morphological operations in order to obtain the object positions in a more effective manner. After that, if updation is needed, means the updation process is employed. Here the updation denotes the changes in the object pixels compared to the predicted one. So if the object positions has to be converted means then the locations were modified based on the morphological operations. After that the process move on to the next frames. So this process continues till the complete frames of the input videos. After the completion of the updation processes and the prediction processes, the tracking is employed. The final object positions is represented in terms of a rectangle in order to denote the object location in the video. So after the detection of the object locations, the tracking process is employed. The tracking process continuously identifies the object positions in the complete video. Finally, the performance of the process is measured in terms of error rate and accuracy of the overall process. Let us see the running procedure of the process. If you want to run the code, select the file main.m, which is located in the source code folder. Right click it and click on run file. You will get the process started. So select any one of the video which is present in the dataset. The process will work for the videos in the datasets alone. Since we have provided all the regions for the videos in the datasets, the process will work for the datasets alone. So as we can see, the process is getting executed. The videos were converted into frames and the pre-processing steps were completed. So this is the input video and this is the converted frames. So we have just displayed some 50 frames to show that we have converted the videos up to frames. After that we move on to this pre-processing step. So the basic pre-processing step is employed with the help of the applications of the filters using the median filtering processes. After that the prediction and the estimation steps is going on. This process will take some time for the execution since the process has to be done for each and every frames. So as we can see, this is the estimated positions and this positions and values were represented in a table format here, and this is displayed as images here. Then after that, the based on the identified object positions, the positions were estimated in order to refine and identify the exact object positions all over the video frames. Then as we can see, the tracking of the process is started. So the videos, the objects in the frames were tracked all over the frames in the video. This tracking process is done based on the object position estimated in the previous steps. So the detected object positions were uh, tracked continuously, and as we can see, the detected portions were written in the folder named track. The objects were written in the folder name object. The predicted objects, final predicted objects were written in the folder called OCC object. So similarly, the results obtained were saved in the folders here, and the tracking process is going on continuously till the end of the frames. So after the completion of the complete tracking in the video frames, the performances of the processes were measured, and the measured performances were displayed in the format of a graph. Thus we have calculated accuracy and error rate as the overall performance of the process. We have tracked the objects all over the video frames, and we have measured the performances based on accuracy and the error rate. Thank you.